Hello everyone, today we are going to look at the normal distribution. So a key idea to help you understand the normal distribution is to really be able to connect it to frequency distributions. So frequency distribution, if you recall, is sort of like how do we graph it using a bar chart or a histogram of some sort. So you may notice on this slide we've got all these bars, right? And the bars are working their way up and they represent different intervals of data, and they go up to this high point and then they start descending from there. And over it, there has been a smooth curve drawn. This curve represents the normal curve. So the idea of the normal curve is it approximates this symmetrical bell-shaped frequency distribution. So instead of making the bar chart for all of our data that's distributed normally, we just draw the smooth curve, which represents that symmetrical distribution of data where the majority of the data is down the center and it is symmetrical on either side. So key features of the normal distribution. First, it is bell-shaped. Second, it's symmetrical about the mean, which is pretty much bell-shaped. So if we are saying that here's our normal distribution, which by the way, the x-bar cuts it in half, so it's 50% to the left and 50% to the right is the distribution of the data. That helps us figure out the probability of certain events occurring, okay? And so the area under the curve is the probability, and it's also the percent of the data that falls in that range. So let's look at an example where it's applied. The mean height of players in a basketball competition is 184 centimeters. If the standard deviation is 5 centimeters, we're sort of going to ignore this what percentage of them are likely to be for right now. What we really want to do is sketch a normal distribution and label it with the measures appropriate to this data. So it's going to look like this. So this is my x-bar. My x-bar goes down the middle. My x-bar equals 184. So this is 184. So what we really want to do is create a number line down here relative to our mean and standard deviation. Our standard deviation is 5. So my next point on the interval is going to be 184 plus 5, which is 189. And then I'm going to add another 5, and it's going to be 194. And I'm going to add a third 5, and it's going to be 199. And you only go out 3 standard deviations. And then you need to subtract 5 to the left. So 184 minus 5 is 179. 179 minus 5 is 174. And 174 minus 5 is 169. So this is what the distribution of the data looks like for the heights of these basketball players, okay? So you really want to be able to sketch out this curve, figure out where your x-bar is, where your mean is, and then make a number line using the standard deviation as your units. And then we want to erase it promptly. Okay, so now we're going to use this to find the probability that a randomly selected person will be between 174 and 199. So this might be where it would be helpful for you to put your probabilities in or your percentages in. So this is a 34. 34. And the more you write it, the easier this becomes. 13.5, 13.5, 2.5, 0.5, 2.5, 0.5. Okay, so if I'm looking to find the probability that a randomly selected person is between 174 and 199, that means I'm starting here and I'm going up here. So the probability that a person is going to be in that height range is equal to the percent of people in that height range. Okay, so all I want to do is add up my parts. 13.5 plus 34 plus 34 plus 13.5 plus 2.5. So that is going to equal 97.5. So that would be a percent. So as a probability, a lot of times it's just written as that decimal, 0.975. Either one is acceptable. Okay? So then we want to find the probability that a randomly selected player will be, not sure what happened when I typed this, taller than 179. Okay, so looking at my distribution again, 179 is here. So it's all the data greater than that 179. So I know this is 0.5, 2.5, 13.5, 34, and 34, except that's 43. Okay, so the probability that they'll be taller than 179, you just add those up. Okay, so it will be 84%, which is the same as 0.84. So really, once you start getting used to the normal distribution, you're going to be able to find some shortcuts to this. You might realize that, particularly for the taller than 179, if this is my mean, 50% of the data always lies above the mean. So I could have skipped adding all of these values together and just added the 34 plus the 50 and gotten the 84 as well. So now it's time for you to try. The heights of male students in a university is normally distributed with a mean of 170 centimeters and a standard deviation of 8 centimeters. Sketch a normal curve and label it with the appropriate values. Find the probability that a randomly chosen student from this group has a height between 154 and 178. So do your best on this, and then I will see you tomorrow in class.